So in this part of the video, I want to talk a little bit more about how we can do data filtering and cleaning in Pandas, because this is some of the most essential tools we need to go and do when working with real data sets. So kind of a large task of data science is associated with cleaning the data. So that's dealing with things like missing values or where the data is not as expected. And then closely related to that is selecting exactly the required data you want to be working with, so somehow filtering the data. We've done a little bit of that before when we use a criterion to select rows of our data. So querying a data frame is a bit more flexible than we've done with the simple criterion of true and false values. So the .query method allows us a way to very flexibly specify what parts of the data set we actually want to go and do by simply giving a suitable expression. So an example here, I've done df.query and then I give it a string where I write down essentially a Python expression for the data I set. So I said I want the intelligence values to be less than 70 and the alignment to be good. So in other words, what I'm asking for here is which of my characters are heroes without a super high intelligence. And it turns out to be Captain America. So that expression I'm passing in the string there is just a regular Python expression, except that the columns are being interpreted as variables. We're interpreting the variables as the column names. Of course, that doesn't work if the column name is something which can't be a Python variable. So if you have a space in a column or a column that starts with a number, then you can't use it like this because it won't be able to work out what you're referring to. Another thing we can do is we can select the columns which have a particular data type value. We can select the columns by their D type. And that's done simply with the df.selectDtype method, and then I tell it which data types I want to include, and it gives me a few shortcuts. So I can, for example, specify I want a thing which is a number, meaning a thing which is either an integer or a floating point number. So in this case you can see it's pulled out the columns with the integer scores, but also the total column, which is a floating point number. Another very important thing to be able to go and do is to find and remove duplicate values. So it's not uncommon to have a duplicate value in your data frame, and you probably don't want to waste time processing things which are just simply duplicate data. So what I'm going to do here is I'm going to go and create a new row in our column called new hero, which is essentially just a copy of the values for Batman. So if we then ask it for what are the duplicated values in our data frame, then you can see everything is false, meaning all our superheroes are not duplicates, until we get to new hero at the bottom. It comes back and says true. And that's because all of the values of the columns in the data frame for new hero are the same as all of the values for Batman. And so it's identified that new hero is a duplicate value. Notice, however, that it's only looking at the values of the columns and not at the index, not at the label. So although Batman and New Hero have different names, it's decided because all their scores are the same that they must therefore be a duplicate. If I want to check is it a duplicate index, then I can simply do that by asking it to find me the things that are. The other thing to notice is that it decided that New Hero was the duplicate. If instead of that we wanted to have Batman, the first thing be the duplicate, then we just do keep equals last into the duplicated method, and then it'll, when it finds a duplicate pair, it'll make the last value of the duplicates the one that it defines as not being duplicated, and it'll make the first one the duplicate. So as I was saying, if it isn't looking at the index there, it's only looking at the values, So if we want to look for duplicated values, we can just, in the index, duplicated names, we can just use df.index is duplicated. So again, in this case, you can say that what we've gone and done is I've renamed the new hero to be Batman. So here you can see I'm actually using the df.rename function. So that's allowing me to rename either a row in this case, because I've specified index, and I give it a dictionary where I give it the old name and then as the key and the new name as the value. I'm telling it to do in place equals true. And once I've done that, and I've renamed the row, I can now say, is the index value duplicated? And it comes back and tells me that the last one is duplicated because I've now got two Batmen in the data frame. To actually remove duplicates, we can use the true false value as we had before to select the matching rows. So we've used the duplicated to produce a series of true and false values, and then we just simply feed that into .lock as we did before when we were selecting by a criterion. The only thing to notice is that we probably want to keep the non-duplicates and throw away the duplicates, so we can use the tilde operator or the invert operator, which will invert the true and false values the other way around. So here you can see what I've done is I've done df, and then I've selected inverted df.index.duplicated. And now I can ask it, well, what's the index? And you'll see it's gone back and it's taken away that second Batman from the end of the index. I've got rid of it. Another important job is to be able to deal with missing data. So again, in real data science applications, we often find that for some reason or other, a value just isn't there that you were expecting to be there. So it's a missed sensor reading, or it's a survey reading where somebody refused to respond, or it's some stock market data for a company whose shares weren't being traded for a particular day for some reason. Whatever it is, you have missing data. And missing data can be represented in a variety of different ways. So it might be represented as a numpy, not a number value, a nan value, or perhaps as a blank string, or perhaps with some other fixed value to indicate missing data. So Pandas has a variety of ways to try and deal with not a number values. So usually the first step of trying to clean the data where you suspect there are blank values is to fill values that are which are missing with np.nan, because that'll then signal to you that that was where you had a missing value. So in this example, we're going to assume that since nobody can be perfect, a score of 100 must actually be a bad data value of some sort, missing or corrupted. So what I'm going to do is I'm going to use the .replace method to replace all values which are 100 with an np.nan value. So when I do that, I'm going to put this in a separate data frame. You can see that I've now, every time I had 100 score, is now replaced it with an nan value. So that's using .replace to change a value over. So in Pandas, as well as using the numpy not a number value to mean a missing value, or an NA, a not available value, you can also use a whole variety of other things. So we saw before that a none value, the Python none, can be used as a missing value. And also some of the following strings. You're going to have NA and NaN. So these are strings rather than values. Null, none, n/a, capital N/a, hash n/a, nan, capital nulls, question mark. Interestingly, one of the things that you can't use is an empty string. So with an empty string, you have to actually do a replace operation. but it takes a whole variety of things and says all of these are equivalent to saying there is a missing value. So you can now check whether cells have or are not having missing values in them. And so there is a isNaN, so is not available, function, method of a data frame. So if we do that and put into head, you can see that it's now pulling out where there are missing values that have come up as true. And we can do the equivalent. We can ask it for things that are not available. So in other words, functions, values that are available, and that's just the inverse of what we were looking at before. And then the simplest thing you might want to go and do is to forget about all the records where one or more of the values was missing. So to go and do that, we can use the drop NA, so drop not available values. And if you don't give it any other parameters, it'll simply drop all the rows which have one or more not available values in it. Unfortunately, when you do that, you can see we end up with not really very much data left behind at all. We could also drop the columns with missing values rather than dropping the rows. And in that case, we just have to specify axis equals 1. So this is an example of where using axis in the same way that a numpy functions use axis. So axis equals 0 is the rows, axis equals 1 is the columns. And again, you can see that this results in even fewer values where we have values which don't have missing data. If we don't want to simply remove empty values or columns, then we need to go and fill the missing values with some other sort of data. So we can use .replace to do this, but the problem is that there are several different ways that we're using to represent missing values. So as we saw before, there are a whole bunch of different strings. There's also none. There's also np.nan. And so if you just used replace, to capture all of those, you'd have to have a whole bunch of different replaces. So instead we have a .fill now, so fill not available function that will handle all the various possibilities that you might have for a not available function. So in this case, we can go back to our original data and we can fill all of those values which were 100 before with 99.9 instead. And so you can see here, it's every time where we used to have had a 100 value, we now have a value of 99.9.